because of the to send them. So let's start. Welcome again for the to the class, and let me share my whiteboard to you so that we can have a good work on indices and have a good demo over. Okay, let me remove this first. Okay, so this is a whiteboard which you see here right now, and you can
Yeah.
scroll up and down for yourself to see specifically anything that you are not able to get. But yeah, this is where I will explain you everything. Okay, so
Okay.
how will I pronounce your name again, please?
Hello.
Nila, right?
Yeah.
Okay,
Yes.
perfect. Nila, would you like to tell me something about yourself firstly, quickly before we start, just to know about you a bit? Like, what are your specific hobbies? Like normal hobbies, or what do you like to do when you are free? And what exactly or have you done in maths till now, and etc. etc. Whatever you feel comfortable in telling.
Like I play netball and I do swimming. I play piano.
You play
Um,
piano. Okay, that's amazing. Very nice. Very
thank
good.
you.
And
Uh,
okay.
in maths, I'm like, well, right now I just had tests, so I did like fractional indices and like standard form.
Yeah, that's it. That's amazing, amazing. That's a very nice. I mean, let me tell you some of the laws firstly, okay, of indices before we start indices. So this is law number one, actually. Okay, so law one is multiplying indices. So how does it work actually? So multiplying indices work like a to the power m times a to the power n equals to a to the power m plus n. What is this again? This is your first formula that you have, right? A to the power m times a to the power n
Yeah.
equals to a to the power m plus n. This is same base, different powers, and then you do this. Now, example, obviously, I will be giving you obviously two. Before I do give you the example, let's understand law two here, which is dividing the indices. Dividing indices here. Now in dividing indices, you have a to the power m divided by a to the power n equals to a to the power m minus n. Now this thing is what miss so I'm sorry, is you are a boy or a girl?
Go.
Okay, yeah. So here you have am divided by an equals to a to the power m minus n. What is this again? This is you are dividing the indices because the base are same. Again, the powers are different. So you basically write them. Base become one and power gets subtracted in case you are dividing it. Which we will do the quotients also of them. Then law three is about your brackets with indices. So this is called your brackets with your indices. In brackets, you write down a to the power n, power whole power n. This would be a the power m times n, right? This is a to the power m times n is a to the power m times n here. Then you have law 4, which is called power of 0. So a to the power 0 is 1, Nila. A to the power 0 always remember is 1. Like any number has a power 0, it will be equals to 1. Then you have law 5, which is called negative indices. So negative indices is a to the power minus m, which is equals to 1 over a to the power m. Remember that. And I will be giving you these examples also of it. No worries, okay? I'm just telling you all the laws first before I tell you anything else. Law 6, you have fractional indices, which is basically means like if there is something called fraction here, let's say a x and then there is a fraction power a by b over it, then it can be written as root under x, b can be written here, and a power a can be written over this whole thing. Okay, is it clear?
Yeah.
Now, what are indices? If I talk about what are indices, right? Because we are studying about indices, so we should know what are indices. So let me just also tell you that quickly. Maybe you know already, but again, my job is to tell you everything. What are indices? So indices usually is a index, or you can say an index. An index is basically a small number that actually tells us how many times a term has been multiplied by itself. That is the first thing. Second thing, the plural of index is basically indices. There, that is where the word came from. Now, this is some of the examples I will write down for indices, which is basically 4 to the power 3. Let's say we'll start from here. It is 4 to the power 3, which can be written as. Now, what is 4 to the power 3 here? This means that this means that 4 is basically the base. 4 is the base and 3 is the index. And we can read this as 4 to the power 3. Okay. Another way of expressing 4 to the power 3 is 4 to the power 3 can also be expressed as 4 times 4 times 4, which is 64. Why, Nila? Because 4 times 4 is 16 and 16 times 4 is 64. Is it clear?
Yeah.
Perfect. Let's also understand that indices can be positive, negative, or negative numbers. So there is like index form here. Let's say I'll tell you some index form of it before I tell you the formulas, usage, and everything. There is expanded forms and there are value here. So index form is 2 to the power 3, which is 2 times 2 times 2. This will be 8. This is 2 to the power 2, which is 2 times 2, which is 4. This would be 2 to the times 1, which is 2, which is 2 again here. This is 2 to the power 0, which is 1, 1. Okay, value is 1, 1 only. Two, and this is index form to the power 0. Then there can be 2 to the power minus 1, which can be written as 1 by 2 as an expanded form. And 1 by 2 can be written as 0 0.5 as the value. Then 2 to the power minus 2 can be written as 1 over 2 square in the denominator. That would be this. And it can be written as 1 by 4, or real value would be 0 0.25 Nila. And then you'll have last thing, which is maybe let's say one more example, which is this. So this is 1 by 8, which is 0 0.125. So these are some of the values you can know about. Like moving up the rows, we get 2 times larger per row, and then moving down the rows, we get 2 times smaller per row. But yeah, these are some basic parts that you should remember. Now let's obviously have some questions of examples and stuff and how to simplify and do these things. Okay. Did you understand this much?
Yeah.
Are you sure?
Yeah, I'm sure.
Okay, perfect. Let's do some examples here. Let's say, for example, we have to simplify the first question, 4a cube times 7a square. Okay, this is the question. Now, if you need to simplify, you can write down this in expanded form. 4 times a times a times a times 7 times a times a. So if you solve it, Hila, you have to add the indices, which is
Yeah.
a3 and you have a2 here. Add them, which give you 3 plus 2, 5. And you multiply the numbers here. Multiply 7 and 4, which is 28. So this would give you what? 28 a to the power 5. This
Okay.
would be your answer. Okay.
Yeah.
Now let's talk about, now this is the first law, Nila. First law. Quotient on first law. Now the second is, let's say we have dividing indices quotient. Example is 21 a to the power 9 divided by 7 a to the power 2. Now, Nila, how will you solve it? Super simple. You subtract the indices, because I told you, if you see, go over and check when you have this quotient here. Second law, a to the power m divided by a to the power n equals to a to the power m minus n. That means your base should be a only. But here you see the base is 21 here and 7 here. So how will I make the base same firstly? So in that case, Nila, what you can do is, obviously, you can, in that case, you can write down this as a to the power 9 divided by 7 to the power a square. For the variable, for the coefficients, okay, for a part, which is like a here, these are called the things that are attached to the numbers. They are what? Do you know that? Variables. And the numbers are coefficients of them. They are called in maths, like that is the terminology we use. But fine,
Okay.
we will subtract this and we will divide them, these numbers. So 7 times 3 is that. So 3, and then a to the power, this would be 9 minus 2, which gives you 3 to the power 7. Is it clear?
Yeah.
Nice, better. Let's do the bracket one also. Third law. So the question we have is, let's say maybe a to the power 3 times 4. What will be the answer, Nila, for this? Super simple. A to the power 3 times 4, which would give you a to the power 12. Okay.
Okay.
So this is how simple it is. That is how you do it. Now let's say maybe you have coefficient inside, like let's say the same example of type coefficient I have given you inside is, and then this is the given thing to you. So in that case, what you will do the square to both the things, Nila. Firstly, you do for 10, so 10 square is 100, and a into this would be 3 times 2, which is 100 to the power a to the power 6. Okay.
Okay. Yeah.
Now, because it was demo, that's why I'm explaining you everything and stuff. But whenever it is the, so whenever it is the right time, we can do.
Sorry, I can't hear you.
Yeah, I mean that, Nila, I said that whenever it is the regular classes, I will allow you to do it. I'm just trying to make sure that, uh,
Oh, no.
yeah, make sure that you just see how I'm doing it for now and everything you understand. For negative indices also, Nila, it works like that also. For example, the question is this, -3 and 2. In that case also, Nila, you do the square of 4, which is 16, because -4 times -4, Nila, is 16.
Mm.
And then you have -3, which will be just multiplied. So 16, then you have a to the power -3 times 2, which gives you 16 a to the power -6. So you can also write down this as 16 a to the power 6 if you want to make it positive, like the power basically. So this is how we do it. Okay.
Yeah.
Then I told you anything with a power 0 is 1. So like this, if this is the quotient, Nila, you will be writing this as 12 times 1, which is 12.
Okay.
Okay. Then you also can have the quotients of negative indices, where somebody has written this quotient for you. 2a to the power -3 would be 1 over 2a to the power 3 basically. Right? So this can be what? This can be 2 times 2 times 2, which is 4. 2 times 2, 4. 4 times 2, 8. 8a to the power 3. Is it clear, Nila?
Yeah. Yeah.
So Eventually, obviously, we have some better questions. I'll let you do it. That's enough of explanation. I think you should try these questions and tell me the answer also for them. This is first. This is second. You can do in your notebook and let me know. I give you like 5 minutes to do them.
Does
Please.
the second one does the second one say to the power of 46 and then to
No,
the
not
power of 7?
not 46. It's 40 4. It's this is 4B. B for
Oh,
ball.
okay. Yeah. So a to the power of 4b, and then is that 7b in the
Yeah,
other
yeah,
one?
exactly.
Okay, thank you. Okay, I finished. I finished the questions.
Uh-huh. Okay. So what did you get as an answer for the first few ones? Like, can you tell me one by one? What is the answer for the first?
I got 20 to the power of, no, sorry, 20a to the power of 4.
Okay, that's correct. Second,
I got 108a to the power of 10b.
that's not correct. So I told you seven times six, sorry, six times three is 18. Okay. And 4B, obviously they are in multiplication, so the powers will be add up.
No,
4,
I wrote the wrong question now. I accidentally wrote 18 instead of 3. That's why I got it wrong.
what is your
Sorry.
answer now?
Wait, I need to change it because when I copied out the question, I didn't write 3a to the power of 4b. I wrote 18a minus 18a
Tell me,
to the
tell
power
me,
of 4b.
tell me third one.
The third one, I got a 80b to the power of 15.
Third one,
Third one,
20 times 4 is what?
80.
Yes, exactly. I
I
mean,
said
yes, yes,
80
you're right. And B to
power
the power. B is 5 plus. So you said, I guess, 20, 80, B to the power 15, right?
Yeah,
Yeah, that's okay, yeah, that's fine. That's fine then. Okay, my mistake. I have put it up division sign in my book, my notebook actually. Okay, 42 A this, and then what is the answer for that one? Fourth one?
I got 7 to the power. No, I got 7a to the power of 5.
That's correct. Last one.
The last one I got 36.
That's correct because these are again these are easy questions, Nila. Obviously, these are obviously there would be difficult questions that we will have to discuss and stuff. That I will do with you. Hopefully, did you understood it? Whatever I have explained you, I know that you know this basic already, and I'm pretty much sure you have done it before. But this was just a demo of how we will be doing things. By the way, you will get notes, homework already after the classes. You will get all of that. But this is how the demo like look like. This is how we will do it. Whether you study about anything, in maths or any other subject, also you need help in. I'll be there for you, helping you out. And this is how we're gonna be doing things over. You need homework, we will be providing you homework, and classwork can also be shared with you in the PDF format in case if you need it. So that is also a thing. So
Do
hopefully you
you,
have. Yes, please,
what
please.
other subjects do you teach?
I uh I myself teach all. Usually I'm a software developer, so I teach like till university level, all of these maths, mostly maths, physics, and coding and all of that. So in case I'm in science, in your case, you can say. So science, maths, and coding, programming, real programming.
Um,
As
yeah,
any of this, if you need any help in, I will be there for you to help you out. Okay,
okay.
fine. So I'll inform the coordinator and stuff so to help you out with anything you need. In case you need classwork, you can just text them that you need classwork after the class. Well, I will send you every classwork like after the class whenever you need it. No worries about it. But like yeah, kind of that only. So in case if you need any help, also this is the first demo you had, or you are already having classes with the company?
I already have classes with the company.
Okay, then no worries. So you can just then you know already all mostly all of the things how it works. So not all teachers are same, obviously everything is different, I guess. So but yes, from my side it's like we study like this. You will be shared with your classwork. In case you like it, like you need it, you need the classwork and stuff, PDF formats will be shared with you. And for any such and other queries you have, you can ask me right now in case if you want to anything, like ask anything. And yeah, I would love to answer that before we end here.
Okay, thank you. I don't have any questions.
Okay, perfect, Nila. It's great to have your class here over. I might see you then in the upcoming classes in case we have the regular sessions. Okay,
Okay, thank you.
take care. See you. Bye.
Bye.